Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss chapter 14 Theorems on Area exercise 14 question number 1 to 10 of M.L.aggarwal class 9 mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel.
Here we are going to solve chapter 14, Theorems on Area, exercise 14. To solve the exercise 14, firstly we are going to have some introduction about this chapter and the rules which I am going to use in this exercise frequently. Here we have congruence area axiom. If two figures are congruent, then the area enclosed by these figures are equal. This is the rule here of this congruence area axiom, and then addition area axiom. If a planar region consists of two non-overlapping planar regions R1 and R2, then area of region R is equal to area of region R1 plus area of region R2. Now, firstly, we have theorem 1. A diagonal of a parallelogram divides it into two triangles of uh, equal area. So, this is I'm going to frequently use because we have an identity here that if parallelogram is there and a diagonal divides it into two triangles, so that both triangles are of equal area. Again, we have theorem 2. Parallelograms on the same base and between the same parallel lines are equal in area, and according to that only we have concluded here three rules. Rule 1 is a parallelogram and a rectangle on the same base and the same parallel lines are equal in area. Second rule is area of parallelogram is equal to base into height. Third is parallelograms with equal bases and between the same parallel lines are equal in area. So these are the three rules based on the theorem 2. Now we have theorem 3 here, which is the converse of above theorem only. Parallelograms on the same base and having equal area lie between the same parallel lines. In the previous one we have same base and between same parallel lines, then the uh, parallelogram are equal in area, and now we have parallelograms on the same base and having equal area lie between the same parallel lines. According to that, we have concluded rules here. Rule 1 is parallelogram on equal bases and having equal area have equal corresponding altitudes. So if they have equal base and having equal area, they have equal corresponding altitudes of both the parallelograms. Now, we have rule 2. On the basis of that, parallelograms on equal bases and having equal area lie between the same parallel lines. So if parallelograms are on equal bases and having equal area, this is the same rule as the previous one. Now we have theorem 4 here. Area of triangle is half that of parallelogram on the same base and between the same parallel lines. If here it is a parallelogram, let's say this is the parallelogram and the triangle is like this on the same base of parallelogram and between the same parallel lines. So we have area of triangle as 1 by 2 base into height. Again the rule 2, a median of a triangle divides it into two triangles of equal area. Here we have area of trapezium is equal to half sum of parallel sides into height. And the theorem 4 says that if it is on the same base and on the between the same parallel lines, then area of triangle is equal to half of the parallelogram area. So here area of triangle is equal to half of parallelogram area. So this is the very important thing which I am going to use in this exercise. Now we have theorem 5 as triangles on the same base or equal bases and between the same parallel lines are equal in area. So if the triangles are on the same base and between the same parallel lines, then both triangles are equal in area. Theorem 6 says that triangles on the same base and having equal area lie between the same parallel lines. The same as that in the case of parallelogram, we have discussed previously one theorem, and according to that, three rules are concluded. Triangles on the same base or equal bases and having equal areas have equal corresponding altitudes. Now we have rule 2. If two triangles lie between the same parallels, then the ratio of the areas equal to the ratio of their bases. Means if they are lying between the same parallel lines, then the ratio of both the triangle areas equal to the ratio of their bases. Now we have rule 3 as if two triangles have equal bases, then the ratio of the areas equals the ratio of the altitude. Means if there are two triangles which have equal base, then the ratio of the areas equals the ratio of their altitude here. So these are the rules which I'm going to use frequently. So by heart them and make it to remember also. So let us start solving the exercise 14. Let us solve here exercise 14. First question, we have to prove that line segment joining the midpoints of a pair of opposite sides of a parallelogram divides into two equal parallelograms. So here we have to prove that here F and E are the midpoints. So we have to prove that this ADEF parallelogram is equal to here area of EBCF parallelogram. So we can simply write here as area of parallelogram ABCD. So it will be AB into height. Let's say this is the height here. We will draw altitude here. So this is equal to H. We will let. Now we have area of parallelogram AEFD as equal to AE because this is the base. So AE into H height. So it will be AE is equal to half of AB. So we can write it half of AB into H because E is the midpoint here. Now we have to find the area of EBCF. So we can write it as because EB is half of that, so we can write EB, and again H is the altitude of both the parallelogram, so this will be H only, and this we can write half AB into H. So simply we can write from 1 and 2 as area of parallelogram AEFD from this and area of parallelogram EBCF are equal. So area of parallelogram ABFD, AEFD is equal to area of parallelogram EBCF. So this is the final answer, hence proved here that the line segment joining the midpoints of a pair of opposite sides of a parallelogram divides it into two equal parallelograms. Now let us solve question number 2 here. We have to prove that the diagonals of a parallelogram divided into four triangles of equal area. So here it is given that because in a parallelogram the diagonals bisect at a point, so let it be O. And because they bisect, so it is given to us that OA is equal to OC, and in triangle ACD, O is the midpoint of BC here. We know that AC. So we can simply write if O is the midpoint, we can see that DO is the median here. So if DO is the median, we have two equal triangles that will be ADO is equal to COD here. So we can write area of, because if they both are congruent means area is also equal. So area of triangle AOD is equal to area of triangle COD. Let it be the first thing. Now we have the second point as similarly in triangle ABC we have area of triangle ABO. So area of triangle ABO because BO is the median. So let it be AOB is equal to area of triangle COB. Let it be the second equation here. Now we will take the triangle in triangle ADB. So it will be area of triangle AOD is equal to area of triangle AOB. Let it be the third equation. Now we have the third part as in triangle CDB we have area of triangle COD is equal to area of triangle BOC. Let it be the fourth equation here. Now from first, second and third, fourth we can simply say that area of triangle AOD is equal to area of triangle uh, AOB, and area of triangle AOB is equal to area of triangle COB, and area of triangle COB is equal to area of triangle COD. So from that only we have concluded that area of triangle AOB is equal to area of triangle BOC and this is equal to area of triangle COD equal to area of triangle AOD. Hence from here only we can say that hence the diagonals of a parallelogram divided into four equal triangles. Hence proved from here that the diagonals of a parallelogram divided into four triangles of equal area. Four triangles of equal area. Hence proved from here. Now let us solve first question. In the following figure given below, AD is a median of triangle ABC and P is any point on AD. Then prove that area of triangle APBD is equal to area of triangle PDC. So here we have AD as median of triangle ABC. So we can simply say that these two triangles ABD is equal to area of triangle ADC because these both are congruent triangles if DAD is the median. So here we have area of triangle ABD is equal to area of triangle ADC. Let it be the first equation here. Now we have median of a triangle divides it into two triangles, so that we have concluded here. Also PD is the median here. So we can simply say that of BPD that PBD is equal to area of PDC here. So we can write area of triangle PBD is equal to area of triangle PDC. So this is the second equation. Now we can simply subtract this part. This we have to prove here in the first part. So here we have proved the first part. Now we have to prove the second part. So here we can simply subtract these two equations. So on subtracting first and second, we will get as area of triangle ABD minus triangle PBD is equal to area of triangle ADC minus triangle PDC. So this will be area of triangle ABD minus PBD is equal to ABP, and this is area of triangle ACP. Hence proved from here. This is only we have to prove in the second part of the question. Hence proved. Now let us solve second part. In the figure given below, DE is parallel to BC, then prove that area of triangle ACD is equal to area of triangle ABE. So, because these two triangles DBE and DCE are on the same base and between the same parallel line, so we can simply say that area of DBE is equal to area of DCE from the theorem. So, area of triangle DBE is equal to area of triangle DCE here. Let us put it the first equation here. Now let us write here, we will add ADE to both sides in this equation. So on adding triangle ADE on both sides, we will get here as area of triangle BAE. Area of triangle ABE is equal to area of triangle here on adding DBE plus ADE and area of triangle ACD here. So hence this is only we have to prove in the first part. Hence proved from here. Now let us prove the second part in which we have to prove area of triangle OBD. OBD is equal to area of triangle OCE. So simply we will subtract from this equation, we will subtract the triangle here DOE. So on subtracting triangle DOE from both sides, we will get here as area of triangle DBE is equal to area of triangle, because we will subtract here. So subtracting area of triangle DBE minus area of triangle DOE is equal to area of triangle DCE minus area of triangle DOE. So simply we can write as DBE minus DOE as area of triangle DOB is equal to area of triangle EOC. Hence proved from here. This is only we have to prove that area of triangle OBD is equal to area of triangle OCE. Now let us solve first part. In the figure given below, ABCD is a parallelogram and P is any point in BC, then prove that area of triangle ABP plus area of triangle DPC is equal to area of triangle APD. So simply we can say that here area of triangle APD, because it is on the same base and between the same parallel lines here. So area of triangle APD is equal to half of area of parallelogram ABCD. So now we can say here, because this whole area ABCD is also the sum of area of triangle ABP, APD and DPC. So here we can write area of parallelogram ABCD is equal to area of triangle ABP plus area of triangle APD plus area of triangle DPC. So from here we can say that area of parallelogram ABCD is equal to area of parallelogram ABP, APD and DPC. So simply we will divide this whole equation, first equation, from 1 by 2. So it will be half of area of parallelogram ABCD is equal to area of half of area of triangle ABP plus half of area of triangle APD plus half of area of triangle DPC. So simply here we will put the value of APD, because here a half of area of parallelogram ABCD is equal to area of triangle APD. So we can simply put the value here in this equation. So area of APD is equal to half of area of triangle ABP plus half of area of triangle APD plus half of area of triangle DPC. As here 1 by 2 area of APD, triangle here APD, here area of APD. So we will subtract here. So it will be area of triangle APD minus 1 by half area of triangle APD is equal to 1 by 2 area of triangle ABP plus 1 by 2 area of triangle DPC. So on subtracting we will get 1 by 2 area of triangle APD is equal to 1 by 2, we will take common here. So it will be area of triangle ABP plus area of triangle DPC. We will just cancel out this and it will be area of triangle APD is equal to area of triangle ABP plus area of triangle DPC. This is only we have to prove here in this question. Hence proved from here. This is the final solution of this question, first part. Now let us solve here fourth question, second part. In the figure given below, O is any point inside a parallelogram ABCD. Then we have to prove that area of triangle OAB plus area of triangle OCD is equal to half of area of parallelogram ABCD. So here we will draw a line joining from O to AD and from O to CB. So we will put the point here P and Q. And from here only we can say that PQCD is a parallelogram and PQAB is also a parallelogram. So here, because AB is parallel to, we can say that AB is parallel to PQ here and AP is parallel to BQ. Simply here we have ABPQ is a parallelogram here. Similarly, we have PQCD from here is a parallelogram. Now we will take the triangle here in OAB. Here we have parallelogram ABPQ. Here it is given that it is on the same base and between the same parallel lines the triangle is. So we can simply say that by theorem area of triangle OAB is equal to half of area of parallelogram ABPQ. Put it the first equation here. Now again here also we can do the same process in DOC because it is the same base and between the same parallel lines. So area of triangle DOC is equal to half of area of parallelogram DPQC. Sorry, it is PQCD parallelogram. So this is only, let it be the second equation. Now we will add these both equations. So here it will be area of triangle OAB plus area of triangle DOC is equal to 1 by 2. We will take common and we can write here area of parallelogram ABPQ plus area of parallelogram PQCD. From here only we can write that area of triangle OAB plus area of triangle DOC is equal to 1 by 2 area of parallelogram ABCD, and this is only we have to prove here in this question, hence proved from here. Now let us solve the second part of this question. So here we have to prove that area of triangle OBC plus area of triangle OBC plus area of triangle OAD here is equal to half of area of parallelogram ABCD. So here we have area of triangle OBC plus area of triangle OAB plus area of triangle OAD plus area of triangle DOC is equal to area of parallelogram ABCD. Simply we can write here, we will put the value of OAB plus DOC. Here we have OAP plus DOC as half of area of parallelogram ABCD plus area of triangle OBC plus area of triangle OAD is equal to area of parallelogram ABCD. Now we can simply write area of triangle OBC plus area of triangle OAD is equal to area of parallelogram ABCD minus 1 by 2 area of parallelogram ABCD is equal to, here we can write it as 1 by 2 area of parallelogram ABCD is equal to area of triangle OBC plus area of triangle OAD, and this is only we have to prove in the second part, hence proved from here. Let us solve here fifth question. If E, F, G and H means this E, F, G and H are midpoints of the side AB, BC, CD and DA respectively of a parallelogram ABCD, then prove that area of quadrilateral EFGH is equal to half of area of parallelogram ABCD. So here we can simply write it as, this is given here is that this E and G are midpoints, means AD is parallel to EG and this is parallel to BC. So AD is parallel to EG and this is parallel to BC. So now we can simply write here as, if this is the midpoint, so this parallelogram AEGD, this is a parallelogram and this is also a parallelogram. We can conclude from here that AEGD parallelogram and EBCG are parallelograms here, and if they are parallelograms on the same base EG, we have a parallelogram and a triangle. So we can write that triangle EHG is equal to half of parallelogram AEGD and area of. Here we can write area of, and here also this is area. Now put it as the first equation here. Now we can write area of triangle EFG is equal to area of half of area of parallelogram EBCG. So from here we can put it as second equation. Now on adding first and second here, we can write that area of triangle EHG plus area of triangle EFG is equal to half of area, half we will take as common, so area of parallelogram AEGD plus area of parallelogram EBCG. From here we can simply write that area of triangle EHG plus area of triangle EFG, because this is the sum of whole parallelogram ABCD, so we can write half of area of parallelogram ABCD we can write from here, and this we can write it as area of quadrilateral EFGH. So it is area of, from here we can write this area of quadrilateral EFGH is equal to half of area of parallelogram ABCD. So this is the final thing which we have to prove, hence proved from here. Let us solve here question number 6. In the figure given below, ABCD is a parallelogram and P and Q are any points on the sides AB and BC respectively. We have to prove that area of triangle CPD and area of triangle AQD are equal. So simply we can write it as this DPC, because it is on the same base and between the same parallel lines. So we can say that area of triangle CPD is equal to half of area of parallelogram ABCD. Put it as the first equation here. Now we have area of triangle AQD, so it will be half of area of parallelogram ABCD. Now we can put this as second equation. On adding first and second here, on adding first and second, sorry, from first and second, from these both equation, from first and second we can prove that as this is equal only, so we can write area of triangle CPD is equal to area of triangle AQD. This is only we have to prove in this question, hence proved from here. So this is the final answer, and this is the solution of this question. Here this is only we have to prove that area of triangle CPD is equal to area of triangle AQD, and here proved. Now let us solve here second part. In the figure given below, PQRS and ABRS are parallelograms and X is any point on the side BR, then show that area of triangle AXS is equal to half of area of parallelogram PQRS. So here we can write, because these two parallelogram PQRS and ABRS are on the same base and between the same parallel lines, so we can simply say that area of parallelogram PQRS is equal to area of parallelogram ABRS by theorem. So put it as the first equation here. Now we can simply say that on seeing that ABRS is a parallelogram and AXS is a triangle on the same base and between the same parallel lines. So we can write
area of triangle AXS is equal to half of area of parallelogram ABRS. So this is ABRS. Put it as the second equation here. From these two equations, simply we can write that area of triangle AXS is equal to half of area of parallelogram PQRS, and this is only we have to prove in this question, hence proved from here. Because ABRS here is equal to PQRS, so simply we can write this part. Now here we have seventh question. D and F are midpoints of side BC, CA and AB respectively of a triangle ABC. Then we have to prove that FDCE is a parallelogram. So as FE is parallel to BC here and FE is equal to half of BC because F and E are the midpoints of AB and AC respectively. So here we can write that CD is equal to half of BC, and from this first and second equation, because D is the midpoint of BC also, so CD is equal to DB. From here we can write FE is equal to CD. If FE is equal to CD, so FE is parallel to CD because it is a parallelogram, and here F and D are also midpoints, so we can write FD is parallel to EC. From this only we can conclude that FDCE is a parallelogram. Second thing which we have to prove that area of triangle DEF is equal to 1 by 4 area of triangle ABC. So here we have FDCE, AFDE and BDFE is a parallelogram. We can see similarly we can prove like this we have proved in first part. So here we can write that because in a parallelogram the diagonal divides it into two congruent triangles. So here we have as area of triangle DEC. This DEC is equal to area of triangle FDE, and from here only if this is a parallelogram, this and this are congruent means these three triangles are equal. Area of triangle AFE is equal to area of triangle BDF here. So from here only we can write the sum of these four triangles is equal to the area of triangle ABC here. So it will be 4 area of triangle DEF is equal to area of triangle ABC, and area of triangle DEF is equal to 1 by 4 area of triangle ABC. Hence proof from here we can say. Now the third part is area of parallelogram FDCE is equal to 1 by 2 area of triangle ABC we have to prove. So here we have as area of a parallelogram FDC is equal to the sum of the two congruent triangles DEF and DEC. As these two are congruents and equal, so we can write 2 area of DEF, and then we will put the value of DEF from here. This will be 1 by 4 area of triangle ABC. On cancelling 2 and 4, we will get 1 by 2 area of triangle ABC is equal to area of parallelogram FDCE. This is only we have to prove in this part, hence proof from here. Now let us solve here eighth question. In the adjoining figure, DE and F are midpoints of the sides BC, CA and AB respectively of triangle ABC. Then prove that BCEF is a trapezium and area of trapezium BCEF is equal to 3 by area of triangle ABC. So here we have three parallelograms BDFE and DCFE, and here AFDE. So these are three parallelograms and the diagonals divided into two equal congruent triangles. So here we can write that area of triangle FBD and area of triangle EDC plus area of triangle AFE, and here area of triangle FED is equal to area of triangle ABC. So simply we can write it as area of 4 area of triangle, because these are equal only DEC we can write. So here we have DEC is equal to uh, area of triangle ABC. So here we can write area of triangle DEC is equal to 1 by 4 area of triangle ABC. Put it as the first equation here. Now we can write that if here we have to prove that BCEF is a trapezium. So as here we have FE as parallel to BC, FE parallel to BC, and FE is equal to half of BC, and again ED is parallel to AB,
and ED is equal to half of AB. Then we have FD is parallel to AC and FD is equal to half of AC. So here we can simply see that these are parallel. Means if FE is parallel to BC, we can prove that. Hence, BCEF is a trapezium, and from here only we can write the area of BCEF. Area of BCEF is equal to area of these three triangles, means area of triangle BDF plus area of triangle FDE plus area of triangle DEC. And as we have above proved that these four triangles are equal, means these three triangles are also equal. So here we can write area, three area of, sorry, here it is three area of triangle DEC. So it is triangle DEC from here, and this is equal to area of BCEF. So from here only we can put the value of DEC, area of DEC. So it will be 3 into 1 by 4 area of triangle ABC. So this is equal to area of trapezium BCEF. Hence proof from here, this is only we have to prove in this question, equal to 3 by 4 area of triangle ABC. Hence proof from here. Let us solve here 9 first part. In the figure given below, the point D divides the side BC of triangle ABC in the ratio M ratio N. Then prove that area of triangle ABD is equal to ratio area of triangle ADC is equal to M ratio N. So here we can write, firstly we have to prove this part. So for proving this we can write area of triangle ABD, that is this ABD is equal to half into base into height. So from here we can write that area of triangle ABD is equal to 1 by 2 into BD into AE here, and area of triangle ACD is equal to 1 by 2 into bases BC here into AE here. So put it as first and second equation. On dividing here first and second, we will get area of triangle ABD divided by area of triangle ACD is equal to half AE will be cancelled out, and this will be BD by DC. And here it is given that BD is M and DC is M ratio N. So it will be M by N. This is only we have to prove in this question, hence proved from here. Let us solve 9 second part. In the figure given below, P is a point on the side BC of triangle ABC such that PC is equal to 2BP, and Q is a point on AP such that QA is equal to 5PQ. Find area of triangle AQC ratio area of triangle ABC. So from here we can simply write it as PC is equal to 2BP. This is given to us, and here we can write this whole BC. Firstly, we'll write BC by 2 is equal to BP, and then here BC is equal to BP plus PC, because here in this line BP plus PC is equal to BC. Now we will put the value of BP here, which will be PC by 2 plus PC. Taking LCM, we will get here 3PC divided by 2 equal to BC. So from this part, as if the two triangles have same altitude, by theorem we have studied previously also, that if two triangles have same altitude, then the ratio of their bases is equal to the ratio of their area. So here BC BC by PC is equal to 3 by 2. Here BC is the base of triangle ABC and PC is the base of triangle APC, and here altitude is same of both the triangles. So from here we can write area of triangle ABC divided by area of triangle APC is equal to 3 by 2. From here we can write, and here we have this as area of triangle APC. So area of triangle APC is equal to 2 area of triangle ABC divided by 3. So this is the ratio here. Now, as the given information is QA is equal to 5 PQ, so we can simply write this part as QA, because this AP whole we can write it as a sum. So AP is equal to QA plus QP. So this will be AP, and here we can write the value of QA. So AP is equal to 5 PQ plus QP here, or we can write it as QA divided by 5 is equal to PQ. So instead of PQ, we can write the value of QA. So it will be QA plus QA divided by 5. We will take the LCM here, and this will be 6QA plus QA divided by 5 equal to 5QA here, and this will be the sum will be 6QA divided by 5 equal to AP. From here we can write AP is equal to 6QA divided by 5. This will be QA is equal to 5 by 6 divided by AP from here. As again, if in both the triangles, if the altitude is same, then the area of the triangle has the same ratio. So here we have QA is the base of triangle QAC, and AP as the base here of triangle APC. Here altitude is same, so we can simply write it as area of triangle AQC equal to 5 by 6 area of triangle APC. From here we can write it as, because area of triangle APC we have previously find only, we will put the value here 5 by 6 divided by 2 by 3 area of triangle ABC. So this will be ABC. We will cancel out this part. This will be 3, and here it will be area of triangle AQC is equal to 5 by 9 area of triangle ABC, and this is only we have to find the ratio of area of triangle AQC and ABC. So we can write it as area of triangle AQC divided by area of triangle ABC is equal to 5 by 9, and this is only we have to find in this question. So this is the final answer in this question. This is the solution of the 9 second part here. Now let us solve here 9 third part. In the figure given below, AD is a median of triangle ABC and P is a point in AC such that area of ADP and ratio of area ABD is equal to 2:3. Then find AP ratio PC. So we have to find this value. Here we have area of triangle ABD is equal to area of triangle ADC, because AD divides it into two congruent triangles, and it is equal to half of area of triangle ABC. From here we can write, it is given to us area of triangle ADP ratio area of triangle ABD is equal to 2:3, and here ABD is equal to area of triangle ADC. So we can write area of triangle ADP divided by area of triangle ADC is equal to 2:3, and we know that if two triangles have equal altitude, means if this has equal altitude, then their bases have the same ratio as that of the area of triangles. So we can write here, in triangle ADP we have PC, it is AP divided by, here this is AC, base of ADC, so it will be 2 by 3. From here we can write AP is equal to 2 by 3 AC, and PC is equal to AC minus AP, and that is because PC is equal to AC minus AP. By the diagram also we can see, and AC minus AP we can put the value as AC minus 2 by 3 AC equal to AC by 3. And now we have to find the ratio of AP ratio PC in the first part. So we will put the value as AP ratio PC. AP we have found above as 2 by 3 AC and PC as AC by 3. So we can simply write it as 2AC divided by 3 into 3 by AC. AC will be cancelled out, 3 will be cancelled out, and this is equal to 2 ratio 1. Means the first thing which we have asked is AP ratio PC. This is equal to 2 ratio 1 in the first question. Now the second part is asked area of triangle PDC ratio area of triangle ABC. This is asked. So we can simply write here, because PC, here we have PC is equal to AC by 3 as we have found, and now PC by AC is equal to 1 by 3. As in area triangle PDC we have PC as the base and ABC we have as, because it can be same altitude on the AC, so it has base as AC. So we can simply write it as 1 by 3. Now we can write it area of triangle PDC divided by area of triangle ADC equal to 1 by 3, and area of triangle PDC divided by area of triangle here ADC is equal to 1 by 3. We will simply put the value of ADC here. It will be area of triangle PDC divided by 1 by 2 of area of triangle ABC, because in the previous part we have found that AD is median, then it is equal to half area of triangle ABC equal to 1 by 3, and from here only we can write area of triangle PDC divided by area of triangle ABC is equal to 1 by 6 from here, and this is only we have to find in this question. So this is the final answer in this question. Now let us solve 10th first part. In the figure given below, area of parallelogram ABCD is 29 cm square. Calculate the height of parallelogram ABEF if AB is equal to 5.8 cm. So we can simply write here area of parallelogram ABCD is equal to 29 cm square, and here we have, because it is on the same base and the same parallel lines, means area of parallelogram ABCD is equal to area of parallelogram ABEF. As both are equal, so we can write this is equal to 29 centimeters square only, because area of ABCD is 29 centimeters square. Now we have to find the value of height. So we can write here area of parallelogram ABEF, and the formula is base into height, so we can write it as base into height, and given to us as AB is equal to 5.8 centimeter. So here area of is 29 centimeters square ABF, and base is AB, because we can take the base as AB, so it will be 5.8, and we have to find the value of height. So from here we can find the value of height as 29 divided by 5.8. Here we will divide this part, so it will be 29 into 10 divided by 58. This will be 10 by 2 from here equal to 5. So this is the final answer in the 10th first part. Now let us solve 10th second part. In the figure given below, area of triangle ABD is 24 square units. If AB is equal to 8 units, then find the height of triangle ABC. So here, as the two triangles ADB and ABC are on the same base and between the same parallel lines, so we can write area of triangle ABC is equal to area of triangle ADC, which is equal to 24 square units. And as AB is given, means base is given of the triangle ABC, so we can write by formula area of triangle ABC is equal to 1 by 2 into base into height. So this will be 8, here it is 24 by this part, and it will be half into 8 into height. So from here we can find the value of height of triangle ABC, which we have to find in this question. So height is equal to 24 into 2 divided by 8. and here this will be 6. So it will be 6 units here. So this is the final answer here in this question. Now let us solve here 10th third part. In the figure given below, E and F are midpoints of AB and CD respectively of a parallelogram ABCD. If the area of parallelogram ABCD is 36 centimeters square, then state the area of triangle APD. So here we have to find the value of APD, as here APD and triangle ABCD are on the same base and between the same parallel lines. So we can simply write area of triangle APD is equal to half of area of parallelogram ABCD. From here we can find the value of first question. It will be half into 36 because it is given to us. So it will be 18 centimeters square. So this is the uh, answer of first part here. Now the second part is name the parallelogram whose area is equal to the area of triangle APD, as here E and F are the midpoints of this triangle AB and CD. Means AE is parallel to DF and AD is parallel to EF. So AEDF is also a parallelogram. If AEDF is a parallelogram, from here we can write area of parallelogram AEDF is equal to half of parallelogram ABCD here. So from here only we can write, if it is equal to half of area of parallelogram ABCD, same as that of area of triangle APD. So area of parallelogram, from here we can write AEDF is equal to area of triangle APD. And this is only we have to find in this second part. Name the parallelogram means triangle APD is the area who is a here, sorry, it is parallelogram AEDF whose area is equal to the area of triangle APD here. So this is the final answer here in this question.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.